check. It is actually recording. Yep, it is. Great. Well, we are ready for the class. Well, I am. Are there any questions from the homework assignment? Has anyone taken a look at it at least? Are there any questions about it?
What questions can we ask you in the lab?
Okay, all right. If it's specific to your implementation, I can answer those questions in the lab. Yep.
So the first one to the screen in assembly, I have to call it a printf.
Okay, how do you call printf in assembly? That's the question, right? Okay, well let's go ahead and take a look at that particular question. Okay, so let me sign in first. There's really not a whole lot of need to sign in, but I'm just gonna, and I cannot type my password today. I'm waiting for the day where authentication is done by biometric means, and I just have to spit at the screen to establish my identity.
Well, it's not all look great. Someone can swipe your spit.
Then they will have to check the freshness of my spit. And I still cannot sign in.
Looks like someone hijacked your account.
No. Sounds like I need to take piano lessons again. Because when you take piano lessons, your fingers can move pretty much independently. But since I haven't really practiced for years, yeah, all that good stuff is going away.
Well, at least you know what happened.
Well, piano lessons does not bring back good memories, so.
Just do it a little bit, it'll come back. Just do it a little bit, it'll come back.
Well, my last piano lesson was a sister, as in a sister in a Catholic church.
Fun.
And she was a French sister in Hong Kong at the time.
She's a roller.
And when my finger is not curved the way it's supposed to, like kind of flat, she would whack me with a ballpoint pen right on my hand here. And one time the pen actually shattered. But only inside. The outside looks okay, but when she opened up in the inside, it's all shattered. So I must have practiced some kind of qigong. So I did internal injury to the ballpoint pen, and there was not a single mark on my hand. But I count myself lucky as a guy, because with the girls with long hair, she would like pull the hair when she's not happy, when she's like upset about the lack of practicing or anything like that. She would just pull the hair of a girl and just shake the head. Yeah, that's a sister.
What about the brothers?
I think she took care of them.
You break down in sweat when you hear a metronome?
No, not really. Yeah, metronome is actually pacified.
I'd rather be beaten.
That's part of baptism, right?
All right. So, getting back to what we are going to talk about today, which is how do you printf in C and C++, but you want to do it in assembly. So what I'll do is I'm going to do a p.c as a program to just illustrate how to do a printf. So pound include stdio.h, and we'll just implement a function called f. Okay, and the only thing it's going to do is to say printf. Let's do something fun here. Okay, x, y, and z, and we'll say printf $d, $d, and some gibberish. There we go. Okay, so we have x, y, z here. Yes, you did not come to the wrong class. This is assembly language programming. It is not C. Sure. All right, so here's the main function. The main function doesn't do anything except to trigger subroutine f. The reason why I put it into a subroutine f is because I want to demonstrate how to write the subroutine f itself, separately. Okay, because that will mirror what you will have to do. Are there any questions about the C code here? Okay, any questions about the C code? Fairly, standard stuff, right? Okay. All right, so let's go ahead and just make sure this program does compile and works the way we are expecting it to work. So if you do a gcc-opp.c, it would compile and give you the executable. and it prints some gibberish numbers because those local variables are not initialized. Okay, so this is perfectly normal. Okay, but the point is, it did make use of the format string correctly, and everything else is working as expected. Okay, it's just that the local variables were not initialized. Okay, so now we're going to do it in assembly. So we'll go ahead and look at p.c on one side. Okay, let's do a side by side here. So p.c on one side, and then we'll have f.uppercase s on the other side, because that's going to be my assembly language implementation. Okay. So the C code is on the left-hand side, and we are going to do the assembly code on the other side, on the right-hand side. There are a few ways to do this. It all depends on how you want to do it. How many people still remember the .asciiz ASCII directive? ASCII's.
ASCII. Oh, there's a Z at the end of it.
Yeah, there's a Z at the end of it, which means it is going to be null terminated.
Oh,
That's what the Z means. It's null terminated. Okay, so the first thing we're going to do is to just do this. Okay, so we'll do a label L1. Okay, whenever I want to do something that I do not know exactly how to qualify, I'm just going to call it L1, and we'll just say ABC, which is not the string that we want to print, because at this point I just want to illustrate what is ASCII is going to do. Okay, and here is subroutine F, and in this case it's not going to do a single thing, because I just want to illustrate what is L1, what is at label L1. So now I do a .global F to export the label F, and on the other side I can now say, okay, F is a function, but let's not look at the C version of this function. So I comment it out using the #if0 trick. Are there any questions about what I am doing here? No questions? Okay, so we are ready to go, ready to assemble, compile, and run the program. Okay. All right, so the first step is to do a gcc-g, because I want to get into the debugger this time, and then -c, because I'm going to compile separately. First the C file, and then the assembly source code, and then I'll do the linking using -o, and one is p.o, whoops, the output is p, the input is p.o as an object file, f.o as an object file, and now we can use GDB into the executable, put a breakpoint into the subroutine F, and just run the program. So now I'm in the subroutine, and I want to find out what is at the label L1. I can say print L1, it's not going to be helpful, because GDB does not understand what is L1. GDB makes a certain assumption that everything that it does not understand is integer. It's an integer, so it does not really quite understand L1 is supposed to be an array of characters, and as a result, it does not know how to print it. Okay, well that's not a big problem. We can get around that problem pretty easily by casting it. So we'll just say, well, look at it as a const char pointer, and we got ABC. Now, at this point, you have to understand that in GDB, it understands what is a const char pointer. When you print a const char pointer, it would automatically assume this is a null terminated string in C and C++. So that means if it knows that C is the last character of the string, there has to be a null terminator right after the C. Are we doing okay so far with those concepts? So label L1 is a valid label. Okay, it is where the string is located. Is that okay? That's the main point of this little demonstration. Okay. Okay, now that we have established how we can declare a literal string in assembly language, the next question is, how do I finish this program? How do I make use of L1, which is invisible to the rest of the program? Because I did not do the .global on L1, so that means the label L1 is only visible within this source file. The linker cannot even see L1. So it's okay, that label does not interfere with anything else. All right, so what we'll do is we'll do the usual thing. We set up the local variables and stuff like that. Old EBP is 0, return address is old EBP +4, We do not have any parameters, so technically speaking, I don't really need to know where's return address because there's nothing after return address that I need to calculate. But this is just a habit. I like to do all the labeling of all the important components on the stack. We do have a few local variables. So in this case, I can say x is the first one, and this one is OEBP minus 4. This 4 is referring to the size of x itself. It is not referring to the size of the OEBP, even though they're both 4. But I want to explain why we have a minus 4 here. And then we have y, which is 4 bytes below x. And once again, this 4 is the size of y and not the size of x. It just so happens that they're all the same. And this is the last one, z is y minus 4, and that would give me all the displacements into all the important components on the stack. So at this point, since I do have local variables and stuff like that, it is best for me to follow the same convention of pushing EBP and popping EBP at the entry point and the exit point, move long, ESP to EBP, and do the reverse at the end of the subroutine. And now, well, last time I did forget to do this step, and one of you reminded me and go, hey, you didn't allocate for the local variable, so I'm gonna do it this time. I remember. So we add long $Z to ESP in order to allocate 12 bytes for my local variables. So that's a typical setup for a subroutine. You get in, you save EBP, you establish the frame pointer, you save space for the local variables, and then you can do whatever you need as a part of the actual subroutine. Are we still doing okay so far at this point? Okay. So the next part is the only part that is doing anything useful in the subroutine F in the C version. We want to print F. Okay, we want to call printf. So what do you do before you call a subroutine that has parameters? You have to push them on the stack. In what order are we pushing those parameters? From last, we push the last one first, so it ends up with the highest address. Now I actually went through the process to explain why that is the case. It's because in C and C++, you can have functions that can take on a variable number of parameters. And in those cases, it is important that you push the parameters backwards and only have the first parameter visible to the subroutine. From the address of the first parameter, because they're all sequential, you can now figure out the address of all of the other ones. And that's why we are pushing parameters backwards. So in this case, what we are pushing is would be z as my local variable. Then we push y as my local variable, push x. And what about the last one? What about the first parameter? What should I be pushing on the stack? Assuming L1 is not ABC anymore and is the actual format string. Okay, let me fix.
Pointer to L1.
Okay.
Well, it's not a pointer.
Well, let me fix this first, just so that it does match the C code. Okay, so now dot ASCII's has exactly the same content as the literal string. The question now is, what am I going to do here? What am I pushing?
Literal value of L1.
Which is using with or without the $?
With
With the $, you are absolutely correct, because the label itself is the address of the string. Okay, so that's why we have to use the immediate operand here. If you do a push L1 without the $, then it's going to use the ASCII code of %d space and %, and try to interpret those 4 bytes as an address, which most likely would map to a location that you cannot access, and therefore you would have a segmentation fault. Okay. Now I'm not going to do it here because it's just something that you can do on your own. But if you change this $, if you remove the $, on line 18 of the assembly version, the program will crash. It will give you a segmentation fault. Well, once we have everything set up, don't forget to actually place the call, okay? Which is a single call instruction. After that, even though it is not necessary, I'm going to reclaim the 16 bytes that have been used by the function call. Okay, so I'm just adding 16 back to ESP, and that's the end of this entire subroutine. It's all done. Okay, Now, obviously, people look at this and go like, hey, since you have line 24, line 22 is not really needed because you are going to recover the stack pointer from the frame pointer anyway. So why are you adding 16 to ESP? Well, what if I have some additional code to add to this later? I don't want to have to rely on, hey, I need to remember that I did not do this, I did not clean up the stack at the time previously, and now I'll be wasting 16 bytes. Wasting 16 bytes does not seem to be a big deal when you guys all have, what, 16, 32 gigs of RAM, on your computer. But it's a matter of, one, it's a matter of principle, and two, if this is recursive, that can continue to chew up memory, chew up unnecessarily an unnecessary amount of memory. So that's why I always clean it up, and I expect your code to do the same. Okay, so you have to be careful to reclaim the space that is no longer useful when you are done with a subroutine call. Okay. All right. So I think we're done. Let's go ahead and see whether it works or not. So we'll once again recompile. Just this time, I just need to recompile the assembly code because the C code has not been changed. And then we do the relink, and then we run it again, and it does about the same thing, not exactly, because the offset is different. Okay, in C code, sometimes it would push some additional stuff as we have seen before, and as a result, it's a different kind of gibberish. But we were able to do the printf with 3 integers printed as well. Question.
So sometimes when, like if you write hello world, and you just compile it down to assembly just to see what GCC is doing, it uses
LEA.
I can't say anything about that because I haven't seen that, I don't think. But it uses puts. Instead of printf, it uses puts.
Put S.
Yeah.
Put string.
Yeah.
Yes.
Is there any like
that is something that GCC does. Okay, GCC is smart. So when it recognizes that you're doing a printf, but you're not actually supplying any, and the format string does not have placeholders, which are the %d, %x, and that kind of stuff, then it will just switch to put s. Now put string is a much economical subroutine. The moment you link with printf, you are bringing in a lot of stuff that is unnecessary. Okay, if you just use put string, it is like this much code. When you bring in printf, it will bring in like this much stuff. Okay, is anyone convinced that printf is going to bring in a lot of stuff? If you think about it, it should bring in a lot of stuff, right? What can printf do? What can it print? It can print numbers in decimal. It can print integers, okay, signed integers in decimal, hexadecimal, and it can print char. It can print strings, and what else? What is the big one? You guys got a question? Floating point numbers. Yes. Okay. It can print floating point numbers. Okay. How many people want to have a homework assignment to implement printing a floating point number in decimal? And you have to implement the whole thing in. I'll even let you do it in C. Do you want to do it?
No.
No, because that is a nightmare. Okay, it is a nightmare. Okay, printing an integer is not too bad. Okay, printing in hexadecimal, easy. Okay, but printing something that is a double precision floating point number and you want to print it out in decimal, I mean that is a nightmare. Okay, I don't want to deal with it. Okay, so can you imagine how much code it has to bring in when printf has no idea what you're actually printing, right? So it's going to bring in every single thing that you can print. It will bring in the logic to deal with every single thing that you can possibly print using printf.
And is there a way to see that?
To see what?
How big that file grows?
Let's take a look. I think we have time to do it now. So what we'll do is we'll write another program just to illustrate that point. Okay. So we're going to say P1. Okay. This time I do not need. So this one will explicitly just. Okay. I'll just illustrate exactly the concept here. Hello. Okay. And 0. In fact, I'm going to do an experiment because I'm kind of curious about one thing.
You still do that include though.
Oh, I just did something really bad.
You
Yep.
overwrote that
No,
file?
no, it's here, but the question is what is in it, right? Oh, it's still here. Okay, that's good. Because when I did something like this, I'm basically telling GCC to use p1.c as the name of the output or the executable, but fortunately, GCC cannot use standard input as the file is compiled because it doesn't know what type of a file it is. So it needs to have a file name so that it knows whether it's a C file or assembly file, so it can choose how to process the file. So it just refused to do anything, and that's why p1.c is actually preserved this time. Lucky me. If I had done AS instead, oh, it would have gone. You know, yep. Because AS can take the input from standard input. Okay, so to fix this, you just have to supply the name of the executable,
I was gonna say,
and
there's
it's
no
okay.
pound- there's no
Sorry,
include.
there's no pound included. It still worked. Okay, here's another question. I know it's not assembly language programming. Since it's just a warning and it seems to be okay, why should I fix it?
It was only a warning.
It was just a warning.
I did.
I think it was just a warning.
Yeah.
Yeah, it was just a warning, which means it did produce the executable. So if it works, you know, why do I need to deal with it? Why do I have to go back and fix, you know, pound include standard IO and now have to recompile? Going through so much trouble.
It won't work.
I don't know.
Well, it would work. It would actually work as well. Yep.
It's improper. You could have a long list and you don't know which one is. It's hard to keep track of.
It's also a bad habit.
Yeah.
Okay, you know, ignoring warnings and not including prototypes when they should be there, not needed, is a bad habit. Okay, ignoring warning is a really bad thing because sometimes the warning can save you a lot of time because the compiler is going through all the trouble to analyze how you use the local variables and whatnot. Sometimes, you know, those warnings is like indicative of an issue in your actual code.
Wait, so this whole time we could have written all our C programs utilizing printf, but never including standard IO.
I think printf may be the only exception to the rule. I'm not 100% sure. Okay, so let's go ahead and run it just to make sure that it does work. Okay, it prints hello, great. And what we'll also do is to do we'll check the size, ls-lp1. That's the size of the program. And we'll strip away the debug information. Well, I didn't actually include any, so that should be fine. There is a program called strip. What it does is it will strip away all the unnecessary stuff in an executable, which results in an executable that has no debug information and no additional stuff that is not needed for the execution of the program. So once you get it, it should not make any difference in this case because I did not compile using GDB. Well, it did get rid of about 2,000 bytes. Okay, so it did shrink down the size of the program. It got rid of some stuff that is not needed in the executable. Okay, so now we'll go ahead and write the other program, which I'll call P2, and we'll do something about the same. Once again, we say printf, and we'll say hello, like that. Except this time, this is my parameter. Yes. So I'm telling printf, the format string is, there's only one thing to print, and it is a string. Where's the string? It's right next to me. Okay? But it does force the C compiler. I don't think GCC is smart enough to figure this one out.
You said that a lot about GCC.
It's an open challenge to the GCC developers, right? Get this one. Yep. Okay, so we'll go ahead and compile this one. GCC-op2 p.c and the complaints. And there are several things I forgot the pound include again. And the semicolon at the end. This is why people like Eclipse. Yeah, because with Eclipse, the moment you type printf and open paren, it will say, oh, I think you also wanted to do a pound include stdio. You have no idea, how much Eclipse can do, especially when it comes to Android app development. Because with Android app development, you're dealing with a huge library coming from Android, and there's no way anyone can actually remember all the methods, all the members of any particular class. So you just type the name of a variable of a certain class, and it go like, "Whoop, okay, these are the things you can choose from, okay? And the moment you say this is an interface of something, it will give you a list too, and it just does all kinds of automated things to make programming not really programming anymore. It's like, oh, I want to choose this, I want to choose that. It reminds me of more of going to a sushi place and just order sushi than actual development. Well, that's why I like assembly language programs a lot more. Okay, so we'll run P2, and it is just printing hello. And I think there's a way to list what kind of symbols are included. I think it's LDD. Okay, let's do it, man. LDD. Print shared library dependencies. Well, maybe don't do it. Okay. Well, it only shows you what library is including, but it doesn't show you the name or the symbols that are being shared. Okay, well, that's...
GDP has no symbol tag? Well, you didn't put no debugging.
I turned off the debugging option. So we'll go ahead and strip P2 as well, and then ls-l, P1 and P2. Okay, it is smart enough. Darn it. Just when I thought it would do the trick, it didn't do the trick. Fine. Now it has to do something, okay? All right, so strip P2. Okay, I think I know what's going on here, because I linked with a dynamic library, and as a result, the code of the library function is not included in the executable. The executable is just calling for a dynamic. In Windows, it's called a DLL, or dynamic link library, which is a dynamically linked library. It's just the same in Linux too, but it can be shared amongst executables. Okay, so you're not putting the code into the executable. So the fair test is to make it compile so that it's using the static version of the libraries. And I do not remember how to do that. That's okay. I know who to ask. GCC link static library. Okay. And I want to find a more definitive source here. Yeah, Stack Overflow is not exactly the most.
Such an awesome site. I don't know why it ranks for so much.
Sorry?
Everything you search in Google gets Stack Overflow.
Because there are so many entries over there. Okay, dash static. On systems that support dynamic linking, this prevents linking with the shared library. On other systems, it has no effect. I think dash static will work in this case. So we'll do a G++ dash OP1 dash static P1.c. Sorry?
So you can use ++ on the C file?
Oh, yeah. Well, it will still defer to the C compiler. P2 dash L P1 P2. P2 is actually a little bit smaller. Doesn't make any sense. Okay, I cannot explain this. Oh, well, I haven't stripped yet. Okay. No, I haven't stripped the program yet. Just so that there's no misunderstanding.
Yeah, because you are recording this.
There we go. It is still smaller. P2 is still smaller. That I cannot. I don't understand why that is the case. I think it's bringing in the whole chunk regardless.
Yeah.
Yep.
Going back to the thing at the beginning, in the homework we have this routine where we have to do the printf, and we
Right.
have to, which is in the C library, but then we have to do an assembly version of that.
Right.
Then when you did your assembly version, we used printf again in the assembly version, which is a part of C, so it's not really assembly, right? So,
Well, you are calling a function that is usually called in C in assembly language.
I thought we were supposed to do an assembly version, but
You are going to write the assembly code to call printf.
okay.
So you can't assume that printf is already done and you're just calling it.
Okay. So calling is the C subroutine. with the
You're
separate-
calling, well, but who knows how printf was actually written, right? For all we know, it can be written in assembly too. It's just callable from C, and since we already know the convention of calling a C callable function, it will be the same way as what we just described today.
Okay. Okay.
Is that okay?
Yeah.
Okay. Any other questions related to the homework assignment? Did that answer the question? Whoever asked the
Yeah,
question?
yeah.
Okay, that's good. Okay. All right. Yep.
So, how do you include a header file into an assembly subroutine?
Pound include?
You can just do pound include?
Yep, but you're not going to pound include the .h file because the .h file contains C syntax. So what you need to pound include is the inc or the include file.
Oh, okay.
Okay. Any other questions? Okay, this one will take some time, so I strongly suggest people to get started early, because just setting up the files, the include file and stuff like that, that will take up a little bit of time already, and that's not even coding the actual stuff in the subroutine.
I have another question.
Yep, go ahead.
How late can we turn this in?
You have 1 week from Tuesday,
Oh,
so next Tuesday is the due date.
So no late.
No late.
Okay.
Yep. Well, that's because we have another homework assignment that I'll be assigning on Tuesday.
That'll be the last one.
Yes, we'll be stacking up the homework assignments. No pun intended. All right. So now that we have the concept or the main concept of a structure done, we are going to do two more things. Okay, we need two more things to complete the treatment. Okay, to complete the understanding of C code that is implemented in assembly. First one is array, and the second one would be pointers. Okay, pointers we kind of touched on it already, but all the pointers that we have dealt with at this point with stir are character pointers. Character pointers are fairly easy to deal with because when you want to move on to point to the next thing, what do you do to that pointer in assembly? You're just adding one to it, right? Okay, well, so an array of characters or a pointer to a character is fairly easy and intuitive to deal with. But what about a pointer to a structure? What about a pointer that is not pointing to something that is simple? What about arrays? Okay, so those are the concepts that we're going to go through today and also next week. Okay. Since we have been talking about structures, we'll just go ahead and stack on top of that pointers to structures today, as well as pointer to a pointer. Okay. Are there any questions about a pointer to a pointer? Are there any conceptual questions about a pointer to a pointer? In C, okay, so not implemented in assembly, about the concept of a pointer to a pointer. Are there any questions about that? Okay, I can just write a simple program to illustrate the concept of a pointer to a pointer.
Just do a pointer to a pointer back to the original pointer.
Sorry?
A pointer to a pointer back to the original pointer.
A pointer of a pointer that goes back to the original pointer. I don't have to go that far. I can have a pointer that points to itself. A void pointer that is initialized to point to itself. Yeah, so that doesn't help to illustrate what is a pointer to a pointer, right? Okay, so since it's a pointer to a pointer, I'm going to call this pp.c. What?
Sorry, but you know.
Yeah, well, that kind of shows us how George's mind worked. Okay, so we have an integer, we have a pointer to an integer, and then we have a pointer to a pointer to an integer. Okay, that's why it's PPI, it is a pointer to an integer. So to make this work, we can say PI equals to the address of I. Now, what happens when you do not initialize PI? What would PI be, whose address is PI going to store when you do not initialize it? Who knows? It's uninitialized, right? It can be the address of whatever, garbage, mostly, right? The same thing applies to PPI. PPI is just a local variable. It is 32-bit long or wide, just like any other pointer. But it is supposed to store the address of a pointer. Okay? Now, all this type information is completely lost when you program in assembly. So PPI. Now, if you do something like this in C, which is the wrong use of PPI, because the address of I is just an integer pointer. But PPI is supposed to store the address of an integer. The C compiler will bark at you. Okay, this is considered an error. It is not a warning. You will not get an object file back. Okay, because it's an error. When you do something like this in assembly, there's no warning. It's like, fine, you want to take the address of this and put it into those 32 bits, fine, not a problem, you will do it, right? So you have to be careful when you deal with pointers, because the type information is now completely gone. Okay, for those of you who know what the ampersand is, one of the tendency is to say, hey, since we need the address of something, maybe we can just do the ampersand of I. That does not work either, okay? It does not work because the ampersand of I does not store, and it's not stored anywhere. You cannot take the address of something that is not stored anywhere. It's kind of like the same thing as taking the address of 1 plus 5, okay? Where is 1 plus 5 stored? We know it is 4, but where is it stored? It's not stored anywhere, okay? It is just an expression, it is just a value. So the address of I is the same way. It is really just a value. It is not stored anywhere else, and that's why you cannot take the address of that. Okay?
In this case, would we cast that?
You can cast it. So if you want to, which I do not understand why you want to do this, you can do it. Okay? Now casting in C and C++ as well. Most of the things that I talk about that is applicable to C is also applicable to C++. When you cast, like what I'm doing on line 8, is basically you are waiving your liability. You're assuming the full liability of the program behaving incorrectly, crashing, causing all kinds of injury and property damage. You're basically signing off you're signing off everything and saying, yes, TAC will assume all responsibilities of this program's misbehavior. Okay? Because doing something like this is basically telling the compiler and say, yes, I know this is not an integer pointer, but let's just say that it is. Okay, I know what I'm doing. Every time you use the typecast operator in C and C++, you are saying, trust me, I know what I'm doing. Okay? And for those of you who are way too young to have watched the Sledgehammer, which is a TV series, a very short-lived one, because I think right in the 2nd or 3rd season, the brutality thing happened, and then they had to can the show. Okay, but in that show, the main character, whose name is Sledgehammer, has a favorite catchphrase, which is, "Trust me, I know what I'm doing." And usually, what happens after that would not be something that you want a police officer to do.
Like shooting the ceiling.
Like taking a bazooka out of his trunk and shoot at something. Yeah. Yeah.
I remember that show.
You remember that show? Yeah. Okay, so this is not what we want to do. Okay, we don't want to do a typecast here. So the only thing that makes sense in this case is to take the address of a pointer. A pointer is a variable. Okay, a pointer is a variable that is storing an address of something. So PI in this case is a variable. Okay, it stores something. It is storing the address of an integer. But because it is a variable itself, it also has its own address. And therefore, we can say, okay, I want to take the address of PI because it is a variable. It exists in memory. And therefore, we can say, okay, I want your location. And then in return, PPI is the one that is storing the address of PI. Are we doing okay so far with this code at this point? Okay. So we'll go ahead and just finish this whole thing. We'll go through GDB because these are very important concepts, not only in assembly language programming, but also in general C and C++ programming. At some point, you will see double pointers, okay? If you have not seen a double pointer or an asterisk of something, you will see it eventually, okay? Those are common concepts used in a lot of programs. Yep?
So if the pointer is like a before previous pointer in a parenthesis, so it's like an end of parenthesis, but it's in a parenthesis before another pointer, so it's the same thing. So like you have a variable in a parenthesis, and it has a pointer on the end, and there's another pointer outside that block. So it's the same, like a
I
different.
cannot visualize the program that you're describing. If you want to, you can come out here and draw it as I go through this process. GDB PP list with a breakpoint on line 7. Go ahead.
So like
Oh,
there's
okay, you
int,
just picked it.
There's
Uh-huh.
a pointer,
Uh-huh.
and there's pointer for like PI. So it has like the same thing, like a 2 pointers.
Well, that means something that is completely different, okay? So, okay, now I understand what you're asking. I can explain it, okay? So I'm assuming this PI is a pointer to an integer. Is that correct?
Yes.
Okay, so the type is like this. Okay, so like that, right? Is that the type of, the intended type of PI? What is the type of PI? You have to let me know what the type of PI is, because that will in return determine what this code is actually doing and whether it makes sense or not.
Let me give you an actual example in the lab.
Okay, all right, that sounds good. So let's go through this particular program first. The first thing I want to show you is PI, and PPI. They are all basically variables because each one has its own address and its own value. Okay, so that's the first thing we'll do. And to illustrate these concepts, oh, I cannot do it yet because I haven't run the program. I have to run the program to stop at the breakpoint first. So I definitely has a value. I also has an address. Okay, is that unexpected? Okay, it's a variable. Okay, it has to live somewhere in memory and it has a value. I can now do the same thing with PI. PI has a value as well, and it also has its own address. Same thing with PPI, it has a value, and it also has its own address. Okay, is that okay so far? I think I'm doing this only to convince you guys that each one, I, PI, and PPI, each one is a variable, okay? And each one has its own value. It's just that what kind of value does it have? Now, right now, all of the values are uninitialized. Okay, so that's why they're all kind of like gibberish. Okay, so if I single step through the program, I'm just going to do the whole thing here. After I do this, I is still uninitialized because I never initialized it. PI is now initialized. It has a particular value, and that particular value turns out to be the address of I. They are the same. Is that okay so far? The PI as a pointer has its own address. As a pointer, it is a variable. So I can say, hey, where is PI? PI has a different address. See, it ends with AC. It does not end with B0. It is its own variable. The address of PI is stored in PPI. But you can push this one step further because PPI is also a variable and it has its own address. So now you can say, hey, where is PPI? The type of PPI is int 3 asterisks and then a whole bunch of gibberish because it is a pointer to a point. Is it the address of an address of the address of an integer? All right. Questions? Nope. Okay. All right. So where are we going to go from here?
Why would you need to go 3D? Why would you actually need to go 3D?
3D?
Yeah, like a pointer to a pointer to a pointer.
Because occasionally you might need that. In case you need to change something, you need to have one more level of interaction. Okay.
Array pointers.
Array pointers are, you mean an array of pointers?
You have a pointer
That would be
to
double
array,
asterisk.
and that array holds another pointer to some other content.
Right. But that would just be a double asterisk, not a triple. All right. So are there any questions about all this stuff here? No questions? Okay. Go ahead.
It's a trivial one, so you don't have to spend too much time on it. But it seems that like TBI is stored kind of far away.
Okay, it's B4, it is next to B0, and then AC is right next to B0 as well. They're right next to each other. Yeah.
So, because B4, isn't that like, that looks like about.
It's 4 bytes away from B0. And B0 is 4 bytes away from AC.
We have B4 and AC. That's memory.
Yeah. And then we have A0 at the top.
Yeah, which is where I is at.
Right. So they're right next to each other. The variables are allocated right next to each other.
Including PPI?
Yeah. Because the address of PPI is ending with is 9B4.
Yeah.
So that is the first one. It actually has the highest address.
I'll just do that myself.
B4,
Yeah.
B0, and then AC. Right. So with these concepts, handled, I'm going to. This is not a data structure class, but we are going to use certain concepts in data structure as an example to illustrate how to use a pointer to structures as well as double pointers. So what I'll do is to introduce the concept of a linked list. How many people know what a linked list is? Okay, so there's a number of people. Okay, for those of you who do not know what a linked list is, this is how I will define it. So linked list, okay, typically I define node.h to represent a particular thing. Oops. If then, okay, there we go. All right, are there any questions at this point? I hope not. Okay, it's all good? All right, so we'll say node has a member called value. Are there any questions at this point? It's fine, right? I mean, this is easier than your homework assignment. Complex has 2 members. Okay, now we'll throw in the one that is a little bit tricky. Are there any questions about this one? What is pnext as a member? It is a pointer, okay? It stores the address of something. But what kind of thing is it storing the address of? Another struct node. Okay, it can be itself, okay, but it does store the address of a struct node. That's it. Okay. Are there any questions about this concept? Because conceptually speaking, I can see how there might be some questions about this because we are in the middle of defining a struct node. How can we make use of this very same structure that we are currently defining, right? Yep.
So at this point we are calling that structure? Or
We're not calling anything. This is a structure. We're not calling anything.
So how we gonna use that structure?
Okay, let me ask you another question. How big is a pointer? Is the size of a pointer dependent on the size of what it is pointing to? When you compare a pointer to a char, how big is it? From your stir homework assignment. How big is a pointer? How many bytes do I need? How many bits do I need to store an address? How wide is EAX? 32 bits, right? How wide is the pointer to a integer? 32 bits. How wide is a pointer to a structure? Even if I don't tell you what structure it is, can you tell me what is the width of a pointer? 32 bits, right? So it all works out because as far as the compiler is concerned, it is saying, okay, line 5, we have a member called value. It is an integer. It takes up 4 bytes in the structure. When it parses line 6, it will say, oh, this is a pointer to a struct node, which is the one thing that I'm defining right now. But you know what? I don't have a problem with that because the pointer to anything is 32-bit or 4 bytes wide. So I'll just allocate 4 bytes for pnext. But it is still circular. It is still circular. Well, it is not circular, okay? Because when it comes time to make use of pnext as a member, that's when the type checking will happen. Okay, the compiler will make sure that whatever you assign to pnext has to be the address of a node. that is when the actual type information struct node is actually used. When the compiler is only trying to understand the structure of a node, it doesn't need to know, what it is pointing to. It just needs to know it is a pointer of some kind. That's all. Okay, is that part okay? Because when I went through this process, I had some questions about okay, but I'm still in the middle of the definition of this structure. How does it work out? Well, once I got into writing compilers, everything just cleared up. It's like, oh, it's just a pointer, 32 bits. There you go. Is that okay so far? How many people have not seen anything like this before because you have not taken data structure yet?
Not like
Well, I haven't seen it, but I've seen it.
Well, but now you have a preview of what is coming. Coming attractions.
Can't wait.
Rated G for general public. All right, well, now that we know what a node is, let's have some fun with it, okay? The first thing we'll do is to have a subroutine to initialize a node, okay? So we'll say node init, and it will take a particular value to initialize the node, and the node is going to be the first thing that we pass to it. And this is different from your current homework assignment as well, because I'm not passing a structure by value. I'm now passing it, I'm using a pointer to pass a structure. Okay, it is not the same thing as pass by reference because I'm using an explicit pointer in this case. Okay, even though the mechanism is the same as passing by reference, it is not considered the same thing. Okay, so this is just a prototype to remind me what I have to do later on, but in this case, I'll do it one at a time. So I'm going to split the screen, and implement node.c. Okay, so we are now actually going to implement the subroutine. Count include node.h. Sorry.
Sorry. And in C, that can't be. You said it before, but I don't know. That struct cannot have a constructor. Correct.
In C, there is no such thing as a constructor.
So that's just how structs are defined in C++. Because you can have a constructor for structs.
Only in CPP, only in C++ you can specify or have a constructor. C does not have any constructor. It doesn't have a concept of a constructor. So when you say, okay, here is a node, it would just allocate a memory uninitialized.
Yeah. So that's what I'm saying. So like in there, if you had written, it'd be like the same syntax that you would have for a constructor, where it would just be struct node, and you put in those exact same parameters that you have in node init. That would it would create an error in this. So yeah, so you would have struct node, and it would look like a function parameter. It would basically be that same prototype, but it would be defined inside the struct, and it would use the node.
Oh, as a method?
Yeah, basically. And
C has no methods either.
Inside the structs, right?
Yeah, C has no methods. It has no class. In many sense, in more than one senses.
Yeah.
And but it's yeah, it has no class. But it's very simple. A structure is nothing more than just saying, okay, when something has a type of this particular struct type, this is how we partition the memory allocation into these members. That's all. That's what a struct is in regular C. Now C++, is basically building on top of a struct. A class is essentially a classy struct. Okay. Yes.
Yeah.
Pun definitely intended.
Yeah.
Okay. But it is based on the same concept. Okay. But on top of having data members, it is also allowing you to specify function members, which we call methods. Okay. But since this class is not about C++, it's not 400. I'm not going to go too deep into it. But to answer your question, there are no constructors in C. When you say struct node n, all it does is to allocate the space needed to have one struct node and call it variable n. But the content remains uninitialized. And there is no way to say, oh, but I do want to have a constructor to initialize a structure. Yeah, the mosquito is here. I think they're talking about mosquitoes.
I kill one.
Yeah, there's another one here. They like me.
Kill it.
Apparently, I emit a lot of carbon dioxide.
The mosquito eater's not doing its work. Mosquito hawk not doing its job.
What?
Mosquito hawk.
Oh.
It's not doing its job.
You need to get a bunch of mosquito hawks.
Are those things that the insects that look like a really gigantic mosquito?
Yeah.
Yes.
Oh, okay.
They don't really
I've been
eat
working on
mosquitoes,
it.
they're gadflies.
I leave those guys alone because I figure, if a real mosquito is that big, I might as well just give up.
Well, you should just fill it full of spiders and mosquito contacts.
Jumping spiders, they are cool.
Tarantulas.
They're not nearly as creepy as black widows. Black widows are really creepy.
Yeah, they're not cool.
Getting bitten by one is definitely not cool.
Rub brown recoils.
Okay, so this is what I'm going to do in Node. In Node init, there are two things that I'm going to do. The first one is to initialize the member v of the structure pointed to by pn as a parameter to whatever value is passed in as parameter v. And then the second one is to say, okay, we'll initialize the next pointer to be 0 because usually that means there is no next item yet. Okay. All right. So we'll just kind of look at this at this point and stop and go ahead and implement just this function. Are there any questions about the C code itself?
So
Is everybody familiar with the point or the dash greater than notation? Because if anyone is not familiar with that notation, I can change it to something that you are more familiar with. No taker? Well, I'm going to show you anyway. You cannot stop me.
Yeah, but that one's messy.
But this is what it means.
Yeah.
That really is what, the dash greater than mean. It really is saying, okay, here is a pointer, but I don't want to use the pointer by itself. I want to dereference the pointer first. What happens when you dereference pn, which is of a struct node asterisk type?
You get the actual.
You get a value which is of type struct node, right? And what can I do with a struct node? It is a structure.
You can currently access the value and you can access the
I can
next
refer
node.
to its members, right? That's what the dot notation is. So that means, the familiar operator that we know as a pointer, which is a dash and a greater than symbol, is nothing more than the combination of a dereference and a member of. Okay. I don't know whether in cisp310 whether the instructor talks about this and basically say, okay, these two things are really the same thing. One is a shorthand because it is easier to type, but they are equivalent in terms of meaning. Okay. In this class, I do want to illustrate line 6 because it is important when you're trying to implement the code in assembly. You have to understand what we are dealing with. All right. So with this out of the way, I'm going to exit the editor right now, and just to make sure that it does compile. Okay. So we'll compile node.c. It does compile. Syntactically, it is all correct. So now we'll go ahead and look at node.c on one side and look at node init on the other side, and this is going to be implemented in assembly. All right. So we have the usual stuff. Switch to the text segment. Dot global node init to export the label of the function itself, and then we'll go through the usual stuff, defining all these offsets. I think the mosquito is right next to me. If you guys have a rubber band, feel free to shoot it, even if it's on me. Because I would much rather deal with the sting of a rubber band than getting bitten by a mosquito. All right. Of the two parameters, which one is next to return address? Pn. Okay, because the first parameter has the lower address. So Pn is right next to return address, and then V is the last one, which is next to Pn. We do not have any local variables, so there's no need to define anything on the negative side of ODBP. So now we are ready to actually define the subroutine. think they're getting bitten by the mosquitoes and they're running outside to get away from the bloodsuckers.
Safety.
Jump in some water.
Or just get some DEET. Alright, so we have the usual entry code and exit code of a subroutine. And now we are ready to specify the actual content of this code. We start with line 5. Okay? I'm not too concerned about the B. Okay, that's a parameter. We can get to it in one single operand. Easy stuff. I'm more worried about the left-hand side. Okay, I want to store the value B, okay, the parameter B, into a member of a structure that is pointed to by a pointer, which is my parameter. So how do I go about doing this?
No idea. No idea.
Okay, that's okay. That's why we're here. Okay. If I do something like this, what is in EAX after line 12 of the assembly code?
Whatever PN, or whatever PN is that
Whatever PN is, right?
Yeah.
So PN is a pointer that makes EAX point to the same place, right? What is PN supposed to point to? Okay, struct N, a struct node, right? So after line 12, EAX would point to a struct node. Is that okay? All right. And in the next instruction, let's see, I'm going to do something here first. So I'm going to move VEBP to EDX. I'm skipping EBX because EBX is supposed to be preserved in a function call. So instead of having to go through the trouble to save and restore EBX, I'm just going to choose a register that can be altered by a subroutine, so I don't have to save and restore. Okay. So I'm just, this is just for convenience purposes. I'm storing, the value of parameter B into EDX first. Okay. So in the next instruction, I can do this. I can finish line 5 of the C code in the next instruction. In other words, I know that we are going to copy EDX, which is V, to something. The question now is, what am I going to do with this part here? Now, you can make the assumption that I have a matching include file that defines node underscore value and node underscore P next to represent the respective offset from the beginning of a structure to the members. Okay, so assuming that we have those labels already defined, what should I put here on line 14 as the second operand, which is the destination?
You're trying to store it into these?
I'm storing into value as a member.
So you gotta go these bytes from the current address that you have, which would be the beginning of the struct, right?
Correct. So we will basically say node underscore value, which is the offset of member value from the beginning of the structure. So we know it's going to be useful. What else do we have to specify? That obviously is not going to be the entire thing.
Where we just put it inside of the EAX. It's not where we're currently.
EAX is a pointer, right?
Yeah.
Okay, so let's think about this. EAX is already a pointer to a struct node. Node underscore value is the displacement of member value from the beginning of a structure. So how do we combine these two using one of the operands that we have already used? Yep, exactly. In parentheses, we specify EAX, the based addressing mode. That's it. That will implement line 5. Yep, go ahead. Question? Oh, okay. Are there any questions about line 14 of the assembly code? Now, it might be helpful to draw a picture, okay, so that you can see that, okay, Pn is pointing to the beginning point of an entire structure. EAX is now a duplicate. It is pointing to the same place. Node underscore value, according to your homework assignment, using the same convention, is the number of bytes of the member value in a struct node from the beginning of a struct node. Okay? So if EAX is pointing to the beginning of the entire structure, and node value is how many bytes the member value is away from the beginning, we can just add them up. Okay? But this is adding those two numbers up and dereferencing at the same time. So we are basically doing two things at the same time, which is what the base addressing mode is all about. Are we doing okay so far with line 14? Because once we're done with line 14, the next instruction or the next statement in C can be done in one additional instruction because we already have EAX initialized.
Oh,
Yep.
because we didn't.
We can reuse it. Yep.
Node underscore value would be part of your include file.
Yeah,
.inc.
I haven't set it up yet, but if I did set it up, that's basically what it would be. Okay. So to finish this program up, it's going to be the next instruction is to move immediate 0, which is the 0 on the right-hand side of line 6 in C, and move it into node underscore p next and %EAX. I do not have to reinitialize EAX because I didn't change it on line 14, so EAX will still be pointing to the beginning of a struct node on line 16 of the assembly code. So it's a quote-unquote shortcut because I don't have to reinitialize. Is that okay? Are there any questions about this code here?
Sorry, I just kind of missed that part with the node underscore value and node underscore pnext. Those aren't just symbolic things, those are things that are actually in the header file you were saying?
It is going to be in the header file.
Okay.
So, so that means, in order for this code to work, it has to do a pound include node.inc.
Okay.
And then in node.inc, right now it is not, it's not automatically constructed, but I can construct it manually. It's just, that it's not going to be responding to any changes to node.h, okay? But assuming that, this is going to be eventually set up to respond to it, this is the actual definition of that file. It's going to say node underscore size. What do you think node underscore size should be?
8.
4 plus 4 is 8. Yep. Now I'm doing everything here by hand, just to save time, so I don't have to set up the include file generator and stuff like that. But in your homework assignment, there is the mechanism to automatically generate the include file, so that you do not want to manually hand edit the include file. I'm just doing it here because I don't want to go through the trouble of doing it. Okay. So once we have this, we can also say the value is 0 bytes away because it is the first member, and then p next is the second member. It is now 4 bytes away from the beginning of a struct node. So assuming that you have a pound include file like this, the other file is going to work. Are there any questions about this particular subroutine, node init? Okay, all it does is you have to allocate a node. Okay, how you allocate a node is up to you. It can be a local variable, but more likely it is a malloc. Okay, it is coming from dynamic memory allocation. Okay. Are there any questions about this part? If there are no questions about this part, we are going to look into the code to add a new node. Okay. So getting back to the prototype here. To add a new node, it's going to look like this. So node insert. So we're inserting a node into a linked list. And this is a good time to draw a picture of what a linked list looks like. Let's say this is a node, a struct node. A struct node has two members, right? It has a member called v, which is the value represented by the node, and it has a pointer, which is the other one. So what if I have two nodes here, two struct nodes? What I can do is to say, okay, I want to store a value of 1 in this one. The value that I'm storing is not really relevant. But I can make this pointer to store the address of the other struct node. Would the type work out in this case? If you look at the type of p next of a struct node, would the type work out here? It would work out, right? Because the p next is supposed to have a type of a struct node pointer. Okay? It is pointing to another struct node. Okay? This one is going to have a 0 here to indicate it is the end of the entire linked list. So this is it's a short linked list with only 2 items. I have the first node storing a value of 1. I I have the second node storing a value of 2. Is that okay so far? So now the question is, how do I insert a node or append or insert depending on which end you want to add it? Well, usually you'll go from the here, okay? These things are all floating in memory. So which means in order to get a handle on a linked list, there will be an external pointer, okay? There will be an external pointer that is just pointing to the first node. Now, this is the usual way of representing a linked list in C and C++. We'll call this one, parameter, well, okay, this is a particular thing, okay? When the linked list is empty, how do we represent a linked list that has nothing in it, that has no node whatsoever?
No pointer in there?
No, we still have this
Oh,
pointer.
this could just be a null pointer. So.
Exactly. When that pointer that is all by itself is a 0, it is indicating that we have a linked list that has a length of 0. It has no content in it. When we want to insert the first item, then we will first have to allocate the storage of this struct node here, and then we have to say, oh, okay, whatever this thing is, copy it over here. This is the first operation, and then the second operation is to make this thing point here, and this is the second operation. Is that okay? Can we do this with a subroutine? Just to do this part here. Okay, so conceptually, this picture is only representing that we have a pointer to a struct node. We just want to change that pointer so it points to a particular struct node. It doesn't do the initialization, it's already handled by another subroutine. The only job of this subroutine is to say, okay, I'm given a pointer to a struct node, I am given a pointer to a struct node here. I need to change the pointer to a struct node so that it is now pointing to the struct node. Sounds pretty simple, right? But we'll first go through a incorrect version of the prototype. Okay. Usually the first pointer is called the head of a list or the beginning of a list, and then the second one is really just a node. So we'll just say P and here. Okay. So we'll just take a look at the prototype that is on the left-hand side of the editor and see if it is going to work okay or not. P head is supposed to be this thing here, and then P node is pointing to the actual node that I want the head to point to. Am I doing okay so far? Okay. So we'll go ahead and write some C code to see whether that is going to work or not. So I'm going to write this in C first. Node insert struct node p head struct node pn. That doesn't sound too bad. I mean, all we need to do is to say pn points to p next is p head, and then p head will end up pointing to pn. Done. Okay? Can everybody kind of see that line 11 is somewhat doing what step 1 is doing here, and line 12 is kind of doing what step 2 is doing. But it is not going to work. It is not going to work because what is p head? Okay, I will give you 3 choices. It is a local variable. It is a parameter. It is something that belongs to somebody else. What is it? It's a parameter, okay? I'm changing a parameter.
Oh, that's
What happens after the subroutine returns? We deallocate all of the local variables as well as parameters. So I'm doing this all for naught because p next is going to disappear. I'm changing the wrong thing. Are you guys getting why this is not going to work? Because this thing here, this singleton pointer, does not belong to the subroutine. It belongs to the caller of the subroutine. So how do you change something that does not belong to a subroutine? A parameter belongs to a subroutine. A local variable belongs to a subroutine. This thing is neither. So how can I make the subroutine update something that it does not own? Okay, pointer to a pointer. I'm so glad that at least nobody mentioned global variables. Because I would have told that person to retake cisp310 in that case. Okay?
With me.
With me, exactly. But since I don't teach that class anymore, that person would have to watch all the videos again. Okay, so that means this prototype is not going to work because I'm changing the wrong thing. I'm changing the parameter, which is useless. It's pointless to change a parameter that is just going to be that will disappear. So what needs to happen here is I do not want to have something like this. I want this to be a double pointer. In other words, this thing is actually outside of this box here. What is passed to me is a pointer to that thing. And I want this thing to eventually point to this node here. Are we doing okay so far with this terminology? Okay? All right, if I change the prototype so the p head is now a pointer to a pointer of a struct node, I have to change the implementation accordingly. Now it is a pointer to a pointer. Now if I leave the rest of the code without changing it, the compiler is not going to be happy. Because p head is now a pointer to a struct node. What is p next as a member of a struct node? It is just a pointer, right? Well, they're of different types. Even though they are both pointers, one is a pointer to a struct node, the other one is just a pointer to a struct node, the types are considered different. And it's not going to work.
So do we got to dereference P next?
Yep. Well, okay. If you just want to get rid of the message, this is one way to do it. Once again, what am I telling the compiler?
I got this.
Trust me, I know what I'm doing, okay? Okay? Which is usually not a good idea. There are very few instances where you really want to do something like this. This is not one of them. Okay, so if this is not the proper way to get rid of this type of error, the other way to get rid of the error is to say, hey, that.
Okay.
So p head is this thing here. It's basically saying whatever I'm pointing to, copy that guy's value to the p next member of the node being pointed to by pn. Okay. And the next line is now going to be, it's going to receive the same change, but this is an even more significant change because I am not changing the parameter p head itself anymore because that would be pointless. I am changing what it points to. But what it points to does not belong to me. It is somebody else's stuff, okay? But that means, that change is going to be persistent. Because when this subroutine returns, that change will stay there. Because p head itself is not changed. It is what it points to that is getting changed. Are we still doing okay so far with this code?
Does Pn exist after this?
Pn would also go away. But it does not mean that what it points to would go away. See, Pn is a pointer to, so even though the pointer is going away, what it points to has a different lifespan. So it's going to be okay. Are we doing okay so far with node insert? In terms of C, okay, in terms of C code, don't worry about the assembly language implementation just yet. Is that okay so far? Let's see, we are all running out of time today, so I can illustrate this next Tuesday along with a new homework assignment that makes use of this kind of thing. But we are not going to do linked list because I have done it already, and that part, the solution of that is already recorded on YouTube. Instead of digging through my own YouTube stuff to delete that video, I'm just going to give you a new homework assignment that is different. I have done BST or binary search tree already, so I cannot reassign that one. I have done the linked list already. I have done arbitrarily long strings already, so I cannot do that either. So I have to think of something for you guys to do that has the nature of something like this.
Hashtags.
Move into a long list.
Hmm?
binary.
Yeah.
But it doesn't hurt to watch those videos, okay, to basically get an idea of what those things are. But at this point, because I'm running out of time today, for those of you who are who's pretty much done with the homework assignment, you can start to think about this. Okay, I wouldn't write any code just yet, but think about it and say, okay, how would I implement line 11 of the C code? How would I implement line 12 of the C code? Okay. In other words, what is that dereference going to do? How do you implement dereference in a subroutine written in assembly? The answer is it's easier than you think. Okay, because we have one particular operand type to deal with dereferencing. Parentheses, yes. But not after a $sign.
No.
It's easier than a C.
Do double parentheses work?
Parentheses are pretty easy.
Wait, is there